Hello guys, welcome to the next session of Java 8 features. In this session, we are going to understand all about functional interfaces and Lambda expressions. So in this session, we are going to cover four most important topics. First one is what are the different ways to implement the interfaces. Second one is what are the functional interfaces. Third one is how we can write the Lambda expressions. And fourth one is what are the inbuilt functional interfaces provided by the Java. And we are going to see one example of how we can use one of the inbuilt functional interface as well. So before talking about the functional interfaces and before talking about the Lambda expression, let's try to understand what are the different ways to implement the interfaces. So here I'm talking about the normal interfaces. So without wasting much more time, let me just quickly try to create one interface inside my package, that is com.youtube.java. So let me just try to create one interface and let me just give the name as, let's say, calculation. So you can give any name again over here, and this calculation method or interface will contain different methods. So let me just try to add few methods like add method. Then let me just try to add one more, that is subtract method or subtract method, like this. And let me just try to add one more, that is divide method. So let's say our calculation interface have these three methods, that is add, sub and div. Now what are all possible ways to implement these interfaces, right? So that is most important question. So we have again some normal ways. So we have to create one different class, create one class, create a class and implement the interface. And again we have second way, that is creating a anonymous class. So we have these two ways. So creating anonymous class. So we have these two ways to implement this particular interface calculation. So let's try to go through all these two ways. So let me just quickly create one class. Let's say first of all calculation IMPL, and this calculation IMPL is going to implement calculation interface. And now as soon as I added these implements calculation, it started to give me the error. So reason behind this is calculation IMPL must have to provide body to all these abstract methods. So let me just quickly try to implement these methods, and we can just override these and we can just give any messages over here. So let me just quickly give one message like add method. Then in similar way, let me just quickly give one simple message like a sub method, and let me just give the message like div method. So I'm just trying to keep it as simple as possible. Now our calculation IMPL is ready. We have overridden all these three methods, that is add, sub and div. Now it's time to use this calculation IMPL. So let me just create one more class which will be a runner class, and this runner class will contain the main method so that we can execute this particular class. Now inside this main method, let me just try to quickly create object of this calculation IMPL is equals to new calculation IMPL. And now what we can do is we can just use our add method. Similarly we can use our sub method, and similarly we can use our div method as well. Now let me just quickly save these and let me just try to run this code. Let's see what happens on the console. So on the console it will simply print these three messages. So now this is the very first way that we generally use to implement any interface. So we create a different class and we use implements keyword, and we just implement the interface, and thereafter we provide body to all the abstract methods which are present into a interface. So this is the very first conventional method to implement any interface. Now we have one second way as well. We can create one anonymous class, and with the help of this anonymous class we can provide body to all these add, sub and div methods. Now to create the anonymous class, first of all we have to understand what is anonymous class. So anonymous class is simply a class which don't have any name. So let me just quickly just try to tell you with the help of practical example. Now what I will just do is I will just delete these calculation IMPL. We don't require it anymore because we just understood these very first way. So let me just try to delete it so that it will not create any confusion for us. And then let me just try to remove this as well from the main method. Now we have only interface, and this interface contains these three abstract methods. Now with the help of this second way, I just want to create one anonymous class, and with the help of the anonymous class I want to provide body to my add, sub and div methods. So to create an anonymous class, what we have to do is we have to just create a new, and we have to use our interface name. So let me just try to use calculation, and then let me just give these curly brackets. And now what we can do is we can hover on these calculations, and then over here you will see one option to implement the methods. So let me just quickly implement this method, and we have to select all abstract methods, and then let me just quickly override these abstract methods. Now as you can see, we haven't created any class. We have just used a new keyword, then interface name, and then we have just used a curly braces. At the end we must have to provide a semicolon, and under these curly braces we are just overriding all our method, that is add, sub and div. Now this particular reference we have to store into these interface reference itself. So let me just use calculation. We can just give any name again, is equals to new calculation. Now over here at this particular point of time, many of the people may say that we cannot create object of interface, but how we are using this new keyword, and how we are trying to use constructor of the interface. So over here let me just tell you one thing quickly. We are not creating object of interface over here. So what this particular line is doing is, so this particular line is creating one anonymous class. So again, anonymous class means class which don't have any name. So this particular line is creating one class which don't have any name, and that class is implementing the calculation interface behind the scenes. So whatever line we just write, for example, let's say generally we just write line like public class, let's say calculation. So we just write it calculation IMPL implements calculation interface, right? So generally we write these particular lines to create any class and implement the interface, but this particular line is exactly same as this particular line, that is new calculation interface name and these two brackets. But over here we are just creating anonymous class. There is no any name to this particular class. This class is basically without any name. So whatever we do in this particular line is exactly same as doing at this particular line, but only one difference is we are just providing a name over here to the class, that is calculation IMPL, but over here there is no any name, it is just an anonymous class. So let me just try to remove this particular line. This was just for a demo, don't take it too much seriously. So we have just overridden these particular lines, and what we have to do is we have to just call it. So calling it very simply, very simple. We have to just use this particular reference, that is calculation, and with the help of this calculation we can just call it. So let me just use it as calculation dot add, then calculation dot sub, and then calculation dot div. So as of now our method don't have any body, so that nothing will get printed. So let me just quickly try to add some body like add method. Then similarly let me just copy this, let me just paste it over here, and let me just change it as sub method, and let me just change it as div method. Now let me just save it, let me just try to run this, let's see what happens. So on the console I'm expecting that it should print the three messages, that is add, sub and div, and it is as expected, it is printing all these three messages. So this is how we can use the anonymous class. So over here we are just creating one anonymous class. Again I'm repeating, anonymous class means a class which don't have any name. So over here we are not creating object of the interface. Behind the scenes this particular line is creating one object is creating one class, child class, which don't have any name, and it is implementing the interface, and this is how it is basically working. So this is the second way of implementing the interface with the help of creating a anonymous class. Now let's talk about the functional interfaces. First of all, let's try to understand what are the functional interfaces. Now let's say if you have one interface in which there is only one abstract method is present. So I am again repeating, let's say if you have one interface in which there is only one abstract method is present. So let's say in our cases, let me just try to remove this from the main method. So let me just keep it blank, and now let's say our calculation interface contains only one abstract method, that is add method, or maybe instead of the add, let me just make it as calculate. It will be more sense. It will make more sense to me. So let's say our calculation interface contains only one abstract method, which is called as a calculate. Now again, to implement this interface, we have two different options. Like we have to just create one class and again implement the interface, and then we have to override this calculate method, and then we have second way, that is we have to create anonymous class. But again, in both of the ways, if you just try to understand, we have to write a lot of code, maybe like a lot of logic, or kind of it's lengthy process, right? But again, if you just see that my calculation interface contains only one abstract method, so why should I waste much more time to just to give a body to this only one single method or only calculate method, right? So it makes sense, like if we have multiple methods, then putting the efforts makes sense. But let's say if we have only one method, one abstract method, then only like to give body to only one abstract method, why should I create one different class, one different file, and then why should I implement that interface, and why should I override this calculate method? So it is becoming a lengthy process. So that so to avoid this, what we can do is we can use a lambda expression. So functional interface is basically an interface which contains only one abstract method. So I'm again repeating the definition, like functional interface is an interface which contains only one abstract method, and to minimize the work, to minimize the number of lines, to provide a body to the functional interface, we don't need to create one separate class, we don't need to create anonymous function anonymous class. Simply we can use a lambda expression. Now again, one more thing that I would like to inform you, like to make sure that this calculation interface is a functional interface, there is one annotation that is called as a @functional interface. Now this annotation will make sure that this calculation interface contains only one abstract method. Now let's say if I just try to add one more method, that is void add, in such a cases you will start getting the error like multiple non-overriding abstract methods. So basically it is simply saying that you are expecting that this calculation should be a functional interface, but functional interface cannot have multiple abstract method, it should have only one abstract method. That's why it is giving the error. So functional interface annotation is really very useful, so you can use it whenever it is required, and whenever you have to make sure that your interface is always remains functional interface. So now let me just quickly save this. So the third way that we have is a lambda expression. Lambda expression, so let me just use it as lambda expression. But lambda expression will only work for functional interfaces. It will only work for functional interfaces, and not for the normal interfaces. So it will only work for the functional interfaces. So again, if you have functional interface, definitely you have these two options as well. You can create one a different class, and then you can implement that class by calculation. Then you can override this calculate method, you can provide the body as well, you can definitely do this thing. Again, you can create anonymous class as well, but just to provide a body to this single method, I don't want to put my efforts, and I don't want to write a lengthy code. So that's why if the class contains if the interface contains only one abstract method, then the easiest way is using the lambda expression. Now let's try to understand how we can write the lambda expression. So writing lambda expression is really very easy. You don't need to create any class and anything. So we have to follow few steps and few set of rules. So let me just come to my runner class, and over here let's try to create a lambda expression for this calculate method. Again, around this calculate method we are going to try out different scenarios. Like as of now, this calculate method don't have any parameters, it don't have any return type. So we are going to add we are going to try this with adding the parameters, adding the return type as well, but as of now let's keep it as simple as possible. So now let's say we have to just provide body to this calculate method. So in such a cases, what we have to do is we have to first of all use interface name, that is calculation, and then we have to give one name as well. So it is just a name to refer, and then we have to give this equals to sign. Now under this calculation reference, we have to store our lambda expression. So first of all, we have to understand what are the different parameters that we have to this calculate method. So as of now, for this calculate method, there is no any parameter, there is no any argument, right? So we have to just give these empty brackets. Then we have to give this dash, and then we have to give this greater than symbol. So this is basically called as a arrow, so you can call it as arrow. So we have to just give the dash, and then we have to give this greater than symbol, and then we have to just give these curly brackets, and under these curly brackets we can just give the body. So let me just give the body as, hey, this is my first lambda. So you can give any body that you want. So I'm just repeating the steps that I followed over here. First of all, we have to understand what are the different arguments this calculate method takes. So as of now, this calculate method doesn't take any arguments, so that's why we have to give these empty brackets, and then we have to just give the arrow, that is a dash and greater than symbol. Then we have to give this curly bracket so that we can write a body. Under this curly bracket, you can just type any message, like any body that you want, you can just type it over here. At the end, we have to give this semicolon, and this entire expression, entire lambda expression, we should store into this interface reference as we have stored over here. So we have to just use interface name, and then we can give any name to the interface reference. Now how we can call these, how we can execute these? So we have to just use this particular name, that is calculation. So we have to use this particular name, and then we have to use the method name. So inside our calculation, we have one method that is calculate. So we have to just call this method, that is calculate. Now let me just save this entire thing. Now let me just try to run this, and let's see what we get on our terminal. So we are just getting like, hey, this is my first lambda, right? So this is how we can write lambda expression. Now again, we can create many different lambdas. So let me just try to copy these, and let me just try to paste it over here, and let me just try to make it as calculation 1, because we cannot give the same name. And let me just try to make it as, this is my second lambda. So just to show you, we can create multiple lambda expressions. I'm just using this particular thing. And now over here, what we have to do is we have to just use calculation1 dot calculate. And now let me just try to run this as well. So again, on the terminal we will get the two different messages, like, hey, this is my first lambda, and hey, this is my second lambda. So this is how we can use the lambda expression. So I think at till this particular point of time, everything is coming like really very easy, right? Now the question is, what if our calculate method contains the parameters? So let me just try to show you like how we have to add the parameters as well. So let me just quickly comment this out, and let me just try to add parameters. So let's say if calculate method takes parameters like two integer number, integer a and integer b. Now let me just come to this runner class, and now let's try to write the lambda for this calculate method. So over here, what we have to do is, again, we have to just use interface name, that is calculation, and again we have to just give one reference name, so calculation again. Again we have to give is equals to, and now we have to understand what are the parameters to this calculate method. So we have two different parameters, that is integer a and integer b. So now inside these brackets we have to give the two parameters. So first parameter will be for integer a and second parameter will be for integer b. So we can give again one dummy names over here. So let me just use x comma y. So we can give any names. Now let me just give the arrow, and now over here let me just give the curly brackets. At the end, inside these curly brackets we can give any body that we want. So I just want to print the addition, so let me just make it as x plus y. Now how these x and y are working behind the scenes, I will just explain you in a moment, so don't need to worry about this as well. And now let me just give semi-comma at the end. Again we have to just call it in this particular way itself. So we have to just call calculation, which is my reference name, dot calculate, and again we have to provide two different numbers. So let me just provide 10 comma 20 like this. Now let me just try to run this code. Let's see what happens on the console. I'm expecting that it should print 30. So as you can see on the terminal, it is printing 30. So now behind the scenes, what is happening exactly? This particular 10 is getting stored into the x. This particular 20 is getting stored into a y. And what we are doing is x plus y. That means 10 plus 20. So 10 plus 20 is 30. And we are just printing this with the help of system.out.println. It is as simple as possible. So now this is the body number 1 that I have provided. Now let's say this particular block works for addition. Now let's say if we have one more scenario where I want to use the subtraction as well. So again we can do the pretty similar thing. We can just copy this expression, we can paste it. We have to just change a name. Again parameters same. So instead of this plus, we have to just give the minus sign, and again we have to just call it. So let me just call it as calculation1 dot calculate, and again we have to provide a numbers. Let's say 30 comma let's say 10. So whatever numbers you want, you can just provide. Again for this 30 will get stored into a x, this 10 will get stored into a y, and we are doing x minus y, that is 30 minus 10, and answer should be the 20. So let's see on the console what we are getting. So on the terminal we are just getting it as 30, which is my addition, and 20, which is my subtraction. So this is how it is basically working. And again if you want, you can give any number of operations, like you can give multiplication, division, modulus, anything, like you can give any number of operations with the help of this lambda expression. Now we just covered one second scenario, like what if our calculate method contains the parameters. Now in some cases calculate method can return some value as well, so we have to complete that scenario as well. So now again let me just comment out these particular things so that it will be a simple for us. And now let me just create some space over here, and now let's say my calculate method takes two different parameters and it returns one integer value as well. So let me just change the name as change the return type as integer. So now my calculate method takes two different arguments and return one integer value. So it is again pretty as simple as like we have already seen. Again we have to just use interface name, that is calculation is equals to, again we have to give the two parameters because my calculation takes two different parameters. Let's say if we have three, like integer c, again we have to just give the three parameters. So let's say if my calculate method takes three parameters, so inside these brackets we have to provide three different parameters. So we have to just use x comma y comma z, and again we have to give the arrow, and then again we have to give the curly bracket. Inside curly bracket we can give we can perform any operation. So let's say I just want to use x plus y plus z like this, and now over here we have promised that we will return one integer value as well. So we have to return one integer value from this particular curly brackets. So what I'm going to do is I'm just going to write return statement in front of it. So return keyword will return the addition of x plus y plus z. So whatever is the addition, it will return this addition. Now again, we have just done with creating a lambda expression. Now it's time to call it. So we have to just call it as calculation dot calculate. Again, we have to give the three different parameters like 10 comma 20 comma 30. Now these three different parameters will be stored. So 10 will be stored into this x, 20 will be stored into a y, 30 will be stored into a z. And what we are doing is we are just doing x plus y plus z. That means 10 plus 20 plus 30, which will become 60, right? But this particular calculate method is going to return us one integer value. So we have to store that integer value in variable as well. So let me just use one integer value, let's say result, and whatever calculate method will return, it will be stored into this result variable. And now we can just store, or we can just print out this result variable like this. So now let me just save this code. Let me just try to run this code. Let's see what happens on the terminal. So on the terminal, it is giving me the result as 60. So I hope you got an idea around this, like how we can create different methods, like different abstract methods in a functional interface, and how we can use these with the help of lambda expression. Again, if you want, you can just create minus operations, multiply operations, division operations. Just make sure that you are giving different names over here. So this is how we can use lambda expression for any functional interfaces. So I hope we have covered every single scenario, and the last thing that we are going to cover in this session is like what are the inbuilt interfaces that we have and how we can use those inbuilt interfaces. So Java provide a lot of inbuilt interfaces. So there are some popular examples. So very first inbuilt interface is a function interface, then we have predicate, then we have supplier, and then we have consumer. So let's say function. So function is again one of the functional interface. So let me just try to open this function. So if you see this function interface having the annotation as functional interface, and it contains one abstract method that is called as a apply. So we have this functional interface as well, and then we have one more. Let's say we have one more, that is predicate, and again this particular predicate interface is again functional interface. You can see the annotation. This predicate contains one abstract method that is a test, which takes one object as a parameter and returns one boolean value. Then similarly we have one more example, let's say consumer. So again this consumer contains one method that is accept. So this accept is obviously the abstract method, and it is only one abstract method which is present into a consumer. You can see this functional interface annotation again. And then lastly we have one more, that is supplier as well. Again the supplier contains one method that is a get method, and again we can see the @functional interface annotation. Now obviously these are the four not only examples. We have different interfaces provided by the Java itself, but these are four that we oftenly use in the projects. These are four that are bit famous, but we have hell lot of functional interfaces provided by the Java itself. Now I will quickly tell you like how we can use one of these inbuilt functional interfaces, because till now we have just used our calculation interface only. But again this is also important that we should know like how we can use inbuilt interfaces as well. So now what I'm going to do is I'm just going to remove every single line from this, and I'm just going to make this main method as empty, and I'm just going to remove this calculation interface as well. So why I'm deleting this? Because it should not like create multiple files, and it should not be confusing at the end. So now we have only one class, that is runner class, and it contains only the main method. Now let's say if we have one scenario, for example, let's try to create one scenario where we want to check the username and password. So if username and password is like admin and admin. So if username and password is admin and admin, then only I will just print one message like you are valid user. Otherwise, if any of these values are different, then I will just print the message like you are not valid user. So let's say this is the scenario that we want to understand. So let's try to create one class so that we can store the username and password. So let me just try to create one class. So let's say user, and this user contains two different values. Let's say private string user name and private string user pass, like this. Let's try to create one constructor and getter setter as well. So let me just create the constructor, and let me just create a getter setter as well. So let me just try to generate getters and setters like this. Now our user class is ready. So let me just come to the runner class, and now let me just quickly create two different objects. So let me just create user u1 is equals to new user, and let me just give the username as admin comma admin. So my username and password is admin and admin. And let me just create one more, that is user2, and over here let me just give some um, random values like xyz, and over here let me just give it as a pqr. So we can give any values. So u1 is valid user, u2 is valid user. So we are able to understand this by the values, but we have to just check this with the one of the inbuilt interface, like inbuilt function interface. So as we have previously seen that we have an inbuilt interface that is called as a predicate, and that predicate takes one object as a parameter and it returns a boolean value as a return type. So we just try to use this predicate over here. So over here we have to just again write the interface name. So we have to just write the interface name, that is predicate. Again, the interface name you can see, and then we have to provide a type as well. So if you see inside these brackets, it is mentioned as t, and that whenever it is mentioned as t, it means like type of input that you are going to provide. So we are going to provide user type of input because our predicate is going to work on u1 and u2. So if you see, the type of u1 and u2 is user. So we have to just give these brackets, and we have to just give the type over here. So now just focus on these brackets, how it is used, and just give the type over here. And again we have to give a name, any name that you can give. So I will just give it as predicate only, right? And now we have to just give the equals to. Now if you see, this predicate takes the object of type t. So over here whatever type we'll provide, that type of object it will take as a parameter. So it has the test method, and that test method takes one object as a parameter. And what type of object we have already mentioned over here. So inside this we have already mentioned that I am going to pass a user type of object. So we have to just give these brackets, and we can just give any name. So let me just give it as user only, or you can give any name, you can give x, like this. And again we have to just give this um, dash and a greater than symbol, which is called as arrow, and then we have to give these curly brackets, and now at the end we have to give a semicolon, right? And now we have to just return one boolean value as well. So now what I will just do is I will just write one condition like if x dot get username dot equals is equals to admin, and so we are going to use AND operator, x dot get user pass dot equals is equals to admin, then you can just return true, otherwise you can just return false, else return false, like this. So it is as simple as that possible. So over here if you see, we are just taking one parameter x. What type of parameter we have already mentioned, so it should be user type of parameter. And then what we are going to check is if whatever we have passed, if the username contains or equals to admin, and if the password is also admin, then return true, otherwise return false. Now over here, let me just try to call this predicate. So again, calling is simple. We have to just use this name, that is predicate, and this predicate contains the test method. So as we can see over here, it contains the test method. So we have to just type dot test, and again, if you see inside this IntelliJ itself, now it is showing like test method will take parameter of type user. So let me just type u1 over here. So we are just passing u1 to my test method. This test method is going to return us a boolean value. So it is going to return us a boolean value, so we can just store it into a boolean result, and then at the end we can print this result as well. So we can just print it as result. Now let me just save this and let me just try to run this. But before running, like what we are passing over here, we are passing the u1 username is admin and admin, so it should return true. Let's see what it returns on the terminal. So on the terminal, I am expecting that it should return true, and now as we can see, it is returning the true on the terminal. Now let me just quickly change it to the u2. Let's see what it returns basically, and for the u2 it should return a false. So let's see what it returns. So it is returning a false over here. So this is how we can use this inbuilt interface. So we have seen one example for predicate. Similarly, you can use the consumer. Similarly, you can use a supplier and function. So there are a hell lot of inbuilt functional interfaces, so you can check out over the Google and you can just try out different scenarios. Now lastly, just let me just quickly tell you one quick rule over here. So let's say inside the curly bracket, if we have only one statement, then there is no any need to give this curly bracket. So this curly bracket will be the optional. For example, let's say if I have only one statement like system.out.println, and I'm just trying to print x over here, it will not work because predicate will require to return one value. But let's say if we have any different interface, so let me just quickly try to create one. Let me just try to remove this, and let me just try to quickly create one because I don't want to put it at the middle stage. So let me just quickly create one again, calculate interface, and this interface again, let's say, contains one method, that is add method, and we have to write lambda expression for this add method as well. So what we have to do is we have to just use calculate c1 is equals to, and then we have to give these empty brackets. Why I am using empty brackets? Because this add method doesn't take any parameter, and over here I'm just trying to print one simple message, like let's say system.out.println and add method, right? I just want to print this message, and at the end we have to just call it as c1.add. Now again, it will normally work and it will just normally print one message, that is add on the terminal. But now if you see inside a curly brackets, we have only one statement, and in such a cases, if we have only one statement, then these curly brackets are optional. If we want, we can give, otherwise we can avoid this as well. So now let me just try to remove this, and let me just keep it without any curly brackets. So let me just try to format this as well. Okay, so we are not using any curly brackets over here, but we are not getting any kind of error, we are not getting any kind of warnings. So let me just try to save it and let me just try to run it. So it will work as it is. So it is going to work as it is. It is printing the add message on the terminal. So this is the rule number one. Like if you have only one statement, then you can just avoid the curly braces. Now let me just try to quickly tell one more rule. So let's say if we have this add method which takes, let's say, two parameters like integer a and integer b, and now let's say if it is going to return addition of it, so addition will be of type integer, so it is going to return the integer. So over here, let me just try to remove this lambda, and again we have to give the brackets, we have to give the two parameters because add method is going to take two different parameters. Then we have to give the arrow, and then we have to just give one curly bracket, and then we have to make it as return, let's say x plus y. So now normally it will work and there will be no any error, so we can just call it as 10 comma 20 like this, and it will again on the terminal it will just simply print the addition of these 10 and 20. So we are not printing it over here, so let me first of all we have to store it inside any variable. So let me just store it inside a result variable, and at the end let me just try to print the result variable. So why I'm just storing it, because if you see our add method is going to return us the integer, so obviously we have to store it into any kind of result or any kind of variable as well. So now let me just save this, and now let me just print this, and it will print 30 on the terminal. So now the rule number 2 is, if we have again only one statement, and if we have only one return statement, then we can avoid these curly brackets and we can avoid these return keyword as well. So let me just try to remove these curly brackets like this. Let me just try to remove this, and let me just try to remove this return keyword as well. So let me just try to remove this, and now if you see, we are not getting any error, we are not getting any warnings over here. It will automatically it will automatically map this particular expression. It will automatically make xyz, and as we have only one statement, it will automatically return the value as well. So rule number 2 is, if we have only return statement inside the curly brackets, then we can remove the curly brackets as well, and then we can remove the return keyword as well. There is no any need to give the return keyword if we have only one statement. If we have multiple statements, then we must have to give the curly brackets, but if we have only one statement, then there is no any need to give these curly brackets and return keyword. So as we can see, we are able to get the correct result, which is 30. So I hope you got an idea around this, like how we can use the functional interfaces and lambda expression in a Java 8, and I tried my best to cover every single scenario that we might face. But if you still have any questions, let me know into a comment section, and I will try my best to help you out in that case. So I hope you enjoyed this session, and I'll see you in the next session.